Welcome back to Autistic Coder's LeetCode series. In this video, we're tackling LeetCode 209, Minimum Size Subarray Sum. This problem is a great example of how to use the sliding window technique to optimize an otherwise brute force solution. We'll break it down step by step and implement an efficient JavaScript solution. Let's dive in. The problem asks us to find the smallest subarray length whose sum is at least target. A brute force solution would check all possible subarrays, summing each one, but that would take O of n squared time complexity, which is too slow for large inputs. To solve this problem efficiently, we use the sliding window technique. The intuition behind this approach is that we don't need to check every possible subarray. Instead, we can maintain a dynamic window that grows and shrinks as needed. This allows us to efficiently find the smallest subarray that meets this sum requirement without redundant calculations. Imagine walking across an array with a window that starts small. As we expand it by adding elements, we check if the sum meets or exceeds the target. Once it does, we try shrinking the window from the left to find the minimum possible length while still satisfying the condition. This balance between expanding and shrinking is what makes the sliding window so powerful. Why does the sliding window approach work well for this problem? The key reason is that the numbers in the array are all positive. Because of this, when we expand the window, the sum only increases. If we reach or exceed the target, the only way to find a smaller subarray is to shrink the window from the left. Since we never need to revisit elements once they've been removed, every element is processed at most twice, leading to an efficient O of n time complexity. Here's a visualization of the sliding window approach as applied to this problem. Here's the JavaScript implementation of our sliding window solution. Let's step through how this code works. First, we initialize left, sum, and min length. Next, we expand the window by adding nums right to sum. If sum is greater than or equal to target, shrink the window by removing nums left. Track the smallest valid subarray length, and finally return 0 if no valid subarray is found. Let's analyze the efficiency of our approach. The time complexity is O of n, since each element is processed at most twice, once when expanding and once when shrinking. The space complexity is O of 1, since we use only a few extra variables. To summarize, the sliding window technique optimizes subarray problems. We expand the window to reach target and shrink it to minimize length. This solution runs in O of n time and uses O of 1 space. A key takeaway: think about when you can shrink your window to optimize problems like this. Thanks for watching, and let's continue learning and growing together. If you have any questions, feel free to ask in the comments section. I'd love to help.